Students, now let us study about compound interest. When money is deposited in a bank for a certain period of time, the interest gained on the principal is added to the principal at the end of the year. For example, if a principal of rupees 100 is deposited in a bank at a rate of 6% per annum, then at the end of 1 year, the interest is rupees 6. This interest of rupees 6 is added to the principal so that the principal for the second year is rupees 106, and the interest for the second year will be 6% of rupees 106. That is rupees 6.36. Then the principal for the third year will be the sum of principal and interest of second year, which is rupees 112.36, and so on for the fourth year, fifth year, and other coming year. This is an example of compound interest. Students, you have observed that in compound interest, the principal increases every year, so that the interest also increases every year. Now look at the example given below that counts the compound interest manually. Calculation of compound interest on rupees 1,000 for 2 years at 10% per annum. For the first year, principal P1 is equal to rupees 1,000. Rate R1 is equal to 10%. Time T1 is equal to 1 year. Hence, interest or I1 is equal to P1 into T1 into R1 divided by 100. Now let us substitute the values. And we write I1 equals to 1,000 into 1 into 10 divided by 100. That gives us rupees 100. Now for the second year, the principal P2 will be equal to the amount of first year. That is, the sum of principal and interest of first year. That is, P2 equals to P1 plus I1. That is, rupees 1,000 plus 100, which gives us rupees 1,100. rate or R2 is same, that is 10% per annum, and time T2 will be 1 year. Now the interest for the second year is given by the formula I2 equals to P2 into T2 into R2 divided by 100. Let us substitute the values herein, and we write 1100 into 1 into 10 divided by 100. That gives us rupees 110. Therefore, when principal rupees 1000 compounded annually at the rate of 10%, then after 2 years it amounts to rupees 1100 plus 110. That is equal to rupees 1210. Here, the compound interest obtained is the difference of amount after 2 years and the original principal. That is equal to rupees 1210 minus 1000. That gives us rupees 210. The formula for the compound interest. Dear students, suppose that the rate of interest is 5% per annum. Then the amount at the end of any particular year is 105% of the principal. Therefore, amount is equal to 105% of the principal at the end of the first year, which is equal to 1.05 into principal. Therefore, for the second year, the principal is 1.05 into principal, and amount is equal to 105% of 1.05 principal into principal, that is 105 divided by 100 into 1.05 into principal, that is at the end of second year. That gives us 1.05 into 1.05 into principal, or 1.05 whole square into principal. Similarly, at the end of third year, the amount is equal to 1.05 whole cube into principal. Here, 1.05 may be expressed as 105 divided by 100 equals to 100 plus 5 divided by 100, or 100 divided by 100 plus 5 divided by 100. That equals to 1 plus 5 divided by 100. Therefore, at the end of the first year, amount equals to 1 plus 5 divided by 100 into principal. At the end of second year, amount equals to 1 plus 5 divided by 100 whole square into principal. And at the end of the third year, amount equals to 1 plus 5 divided by 100 whole cube into principal. Hence, for the rate R% per annum and for n years, amount is equal to 1 plus R divided by 100 to the power n into principal. Or amount is equal to principal into 1 plus rate divided by 100 to the power n. And this is the required formula. And interest compounded annually is interest equals to amount minus principal. That gives us principal into 1 plus rate divided by 100 whole to the power n minus principal. Therefore, interest is equal to principal 1 plus rate divided by 100 whole to the power n minus 1. The other form of the formula are: case 1, if the time period is n years and m months, then the amount at the end of the stated time period is A equals to principal into 1 plus rate divided by 100 whole to the power n plus P into 1 plus rate divided by 100 whole to the power n into m divided by 12 into rate divided by 100. That is equal to principal into 1 plus rate divided by 100 whole to the power n into 1 plus m divided by 12 into r whole divided by 100. Now let us look at case 2. Students, if the compound interest is payable half yearly, then interest is accumulated rate divided by 2% half yearly. Also, n years is equivalent to twice n half years. The amount at the end of 2n half years will be amount equals to principal into 1 plus rate divided by 2 into 100 whole to the power twice n. Now look at case 3. If the rate of interest is different for every year, say R1, R2, R3 for the first, second and third year respectively, then the amount after 3 years is A equals to P into 1 plus R1 by 100 into 1 plus R2 by 100 into 1 plus R3 by 100. Now let us look at a few examples. The first one reads, calculate the compound interest on rupees 8,000 for 2 years at the rate of 6% per annum. Let us look at the solution. Here, for the first year, principal P1 is equal to 8,000. The rate, that is R1, is equal to 6% and time, that is T1, is equal to 1 year. Students, in order to calculate interest, we have the formula I1 equals to the product of P1, T1 and R1 divided by 100. Now let us substitute the given values in the formula and we write rupees 8,000 into 1 into 6 divided by 100. 8,000 into 1 into 6 divided by 100, which is equal to rupees 480. Therefore, the amount A1 is given by P1 plus I1, that is the sum of the principal and interest. We have the principal and we just calculated the interest amount. So let us substitute them in the relation and we write amount equals to rupees 8,000 plus 480, that is equal to rupees 8,480. Now for the second year, principal P2 will be equal to the amount of first year, that is rupees 8,480. The rate or R2 is equal to 6% and time T2 is equal to 1 year. Hence, interest I2 is given by the product of P2, T2 and R2 divided by 100. Now let us substitute the values and we write rupees 8,480 into 1 into 6 divided by 100, that is equal to rupees 84.80 into 6. This gives us rupees 508.80. Therefore, amount after 2 years, that is A2, is equal to the sum of P2 and I2. That is rupees 8,480 plus 508.80. This gives us rupees 8,988.80. Therefore, the compound interest is equal to the amount after 2 years minus the original principal. That is rupees 8,988.80 minus 8,000, which gives us rupees 988.80, and that is the required answer. Now look at this example. It reads, calculate the compound interest on a deposit of rupees 64,000 for 3 years. If the rate percent per annum is 4% for the first year, 5% for the second year, and 6% for the third year. Students, here is the solution. The rate of interest is different for every year. We use the formula A equals to P into 1 plus R1 by 100 into 1 plus R2 by 100 into 1 plus R3 by 100, where A is the amount, P is the principal, and R1, R2, R3 are the rates of interest for the first, second, and third year respectively. Students, we use this formula to calculate the amount after 3 years. Therefore, we write amount equals to rupees 64,000 into 1 plus 4 divided by 100 into 1 plus 5 divided by 100 into 1 plus 6 divided by 100. This gives us rupees 64,000 into 1.04 into 1.05 into 1.06. That gives us rupees 64,000 into 1.15752. That is rupees 74,081.28. Now the compound interest after 3 years is rupees 74,081.28 minus rupees 64,000. That gives us rupees 10,081.28, and that is the required answer. Now look at this problem. It says, at what rate percent compound interest will the sum of rupees 10,000 amount to rupees 11,664 in 2 years' time? Here is the solution. Students, here principal is equal to rupees 10,000, amount equals to rupees 11,664, and number of years, that is n, equals to 2 years. We need to find the value of r. So we use the formula A equals to P into 1 plus r divided by 100 whole to the power n, or rupees 11,664 equals to rupees 10,000 into 1 plus r by 100 whole square, or 1 plus r by 100 whole square gives us 11,664 divided by 10,000, or 1 plus r by 100 whole square equals to 108 divided by 100 whole square. That tends to, cancelling the square of both sides, we get 1 plus r by 100 equals to 108 by 100. That gives us r by 100 equals to 8 divided by 100. That gives us r, or the rate, as equal to 8% per annum. Now let us look at yet another example. It reads, the amount at compound interest on a certain sum of money is rupees 7,986 at the end of 3 years. If the rate of interest is 10% per annum, find the principal. Now let us look at the solution. Students, here amount A is equal to rupees 7,986. The time duration, that is n, equals to 3 years, and rate or R is equal to 10% per annum. We have to find the value of principal, that is P. For this, we use the formula A is equal to P into 1 plus R divided by 100 whole to the power n, which tends to rupees 7,986. Students, we have been given the values of A, R, and N. So let us substitute them in this relation. And we write rupees 7,986 equals to P into 1 plus 10 divided by 100 whole to the power 3, or rupees 7,986 equals to P into 11 by 10 whole cube. Now let us solve for principal here. Therefore, P equals to rupees 7,986 into 10 by 11 whole cube equals to rupees 7,986 into 10 into 10 into 10 divided by 11 into 11 into 11. That leaves us with rupees 6,000. And the required principal is equal to rupees 6,000. And that is the answer. Now let us look at another problem. It reads, find the compound interest on rupees 2,000 invested for 1 by 2 years at 10% per annum. Now here is the solution. Students, here principal P equals to rupees 2,000 time N equals to 1 by 2 years and rate R equals to 10% per annum. We have to find the compound interest. Students, we use the formula A equals to P into 1 plus R by 100 whole to the power n into 1 plus m by 12 into R whole divided by 100, where A stands for amount, P stands for principal, R stands for rate, N stands for time, M stands for month, and R stands for rate. Students, here P is equal to rupees 2,000. R is equal to 10% per annum. N, that is the number of years in time, equals to 2 years, and M, the number of months, is equal to 6. That is half, yeah. Therefore, now let us substitute these values in the above relation, and we write A equals to rupees 2000 into 1 plus 10 divided by 100 whole square into 1 plus 1 by 2 into 10 divided by 100. That gives us rupees 2000 into 1 plus 1 by 10 whole square into 1 plus 1 by 20. That gives us rupees 2000 into 11 by 10 whole square into 21 by 20. That is equal to rupees 2541. Therefore, the interest is given to be A minus P, that is amount minus principal. So we write rupees 2541 minus rupees 2000 gives us rupees 541. Now let us look at this example. It says, on what sum of money will the difference between the compound interest and the simple interest for 3 years at 6% per annum be equal to rupees 5,508? Here is the solution. Students, given that rate equals 6%, the number of years 3. The difference between simple interest, that is SI, and compound interest, CI, is rupees 5,508. Now let the principal be rupees 100. Then simple interest is given by PNR divided by 100, where P stands for principal, N for number of years, R for rate, and SI for simple interest. So substituting the given values in this relation, we write rupees 100 into 3 into 6 divided by 100. That is 100 into 3 into 6 divided by 100. That gives us rupees 18. Now, to calculate compound interest, we have the formula P into 1 plus R by 100 whole to the power N minus 1. That gives us rupees 100 into 1 plus 6 by 100 whole to the power 3 minus 1. That leaves us with rupees 19.1016. Now, the difference between compound interest and simple interest equals to rupees 19.1016 minus rupees 18 when principal is equal to rupees 100. This gives us rupees 1.1016. Students, if the difference between compound interest and simple interest is rupees 1.1016 when principal is equal to rupees 100, if the difference between compound interest and simple interest is rupees 5,508, then principal is equal to rupees 100 into 5,508 divided by 1.1016. That gives us rupees 5 lakh. Therefore, principal is equal to rupees 5 lakh. Here is yet another example. Let's go through it. Students, a man wants to invest rupees 8,000 for 2 years. He may invest the sum at 8% per annum compound interest, compounded half yearly, or he may invest it at 1/2% per annum compound interest, compounded yearly. Which investment will earn for him a slightly better return? Let's look at the solution now. Here, principal is equal to rupees 8,000 and number of years is given to be 2 years. Now, when he invests this money at 8% per annum, the interest being added half yearly, rate is equal to 8/2%, that is 4% per half yearly, and n is equal to 4 half years. Therefore, compound interest is equal to P into 1 plus R by 100 whole to the power n minus 1, where P is the principal, R is the rate, and n is the number of years. Now let us substitute the given values in this relation. So we write rupees 8,000 into 1 plus 4 divided by 100 whole to the power 4 minus 1. That gives us rupees 8,000 into 1.04 whole to the power 4 minus 1. That is equal to rupees 8,000 into 0.16985856. That leaves us with rupees 1,358.87. When he invests rupees 8,000 at 1/2% per annum, the interest being added yearly, the rate is equal to 0.81 by 2%, that is 17 by 2% per annum. N equals to 2 years. Now we have the relation CI, that is compound interest, equals to P into 1 plus R by 100 whole to the power N minus 1, where P stands for principal, R stands for rate, and N stands for the number of years. Students, now let us substitute the given values, and we write rupees 8,000 into 1 plus 17 by 200 whole to the power 2 minus 1. After further calculations, we write rupees 8,000 into 0.177225. Multiplying these two figures, we get rupees 1,417.80. Therefore, the investment of second type will earn for him a slightly better return. That is, rupees 1,417.80 minus rupees 1,358.87, and that gives us rupees 58.93 as the answer.